we'll be looking at equality of matrices. So the property of equality of matrices just simply says that two matrices are equal to each other. So whatever the element in one is basically at the same place in the other. And with that property, it can apply to solving matrices of this nature. So you can put variables in the matrix, in each matrix, and then from that you'll have to calculate what the value of the variables are. So here is an example of an equality question involving multiplication. So first thing you need to do is multiply like a normal matrix. So you'll say the row by each column. So in this case, it will be the first element in the first row by the first element in the second, and then you will continue. So plus second, then you come across first row again by the second column. Then you go to the second row and repeat the process with the first column. And then you do the same thing for second row with the second column. When you get here, you simplify the matrix as usual. So 5 times 1, that would be 5, plus 3, p times 3, that's 3p, or p3, doesn't really matter. The order that you write it in, because multiplication is commutative, 3p is the same thing as p3 in this case. On this side, 5 2s is 10, plus p times 4, 4p. And you come here, j times 1, that's 1j, or you can just write j by itself, plus 8 times 3, that's 24. Come across 2 times j, that's 2j, plus 8 times 4, 32. So if you need extra clarity on multiplication of matrices, you can just scroll through and see the link for that concept. Now, after you get here, all you need to do is equate each term to one of the answers here. So because this term is at the top and it's the first, you go to the first at the top for this as well. So that will be 5 plus 3p is equal to the number here as well. So that's 23. Same principle. Second, this is the first row, second. So you'll do the same thing. So that's 10 plus 4p. And that must be equal to the second thing over here as well. So that's equal to h. So by now you must get the concept that the second here will match to the second here. So that would be j plus 24 is equal to r. And then this will be 2j plus 32. And that will be equal to 46. Now, when you get here, these are all algebraic equations. So, once you know how to solve equations, this will help. You will just apply the method. So now, here you want to get p by itself. So you look at the same side, what is happening to p, and so that's 5 being added, and 3 is being multiplied by it. So you will reverse all of those processes on the other side, or to balance off the equation. So since 5 is being added, you subtract 5 from both sides. 5 minus 5, that gives you 0. So this equals 3p is equal to 23 minus 5. So 3p, 23 minus 5, that gives you 18, so you just write 18 here. And here now, p is being multiplied by 3, so the opposite of multiplying is dividing. So you'll just divide both sides by 3, so that's 3p over 3 equals 18 over 3. So 18 divided by 3 is 6, so p, and 3p divided by 3 is just p. So that will give you p is equal to 6. Now that you have p, you can come over here and write. So that's 10 plus 4. You see p, we have the value of p. So you can put it in a bracket, 6. Or if you want to put multiply by 6, it doesn't matter. So 10 plus 4 times 6, that's 24 equals h. And 10 plus 24 equals 34. And we must remember that the principle of algebra applies. So this means 4 times 6 and not 46. Come down to here. Now you see J plus 24 equals R. Because you have two variables here, you cannot solve this as yet. You must get the value of one of the variables before you can do anything. So because that cannot be solved as yet, you will skip this part and come to the next one that only has one variable. So you'll always try to solve the terms with one variable in it first before you can try to solve the ones with double variables. So 2j plus 32 equals 46. Same principle as up here. You want to get the j by itself. 32 is being added, it's being multiplied by 2. So you'll do the opposite. So that's 2j plus, you can do it the long way. 32 minus 32 equals 46 minus 32. So you can do it the long way, or if you want to take the shorter cut, because you know the principle already of solving equations. So that 32 minus 32, that would leave you with just 2j equals 46 minus 32. That's 14. Now 2j is equal to 14. The fact that 2 is being multiplied by j here, the opposite, divide. So you'll have 2j over 2 is equal to 14 over 2. So j is equal to 14 divided by 2 is 7. Now you come over here. The fact that you have j now, you can put j where it is supposed to be. So j is the same thing as 7, so you can put the 7 there, substitute it in. Plus, bring your 24 back, equals, put back your variable. Now 24 plus 7, that gives you 31. And that is equal to R. So for the equality of matrix, it's just two principles or two concepts being merged together. Concept one is normal multiplication of matrices. And concept two is the process of solving linear equations. So once you're able to multiply matrices and you're able to solve equations, you just merge both of them and you are basically able to answer all questions on the equality of matrices at this level. So I hope this video would have helped you understanding the principle of equality of matrices, and tune in again with Mr. Brown while I explain other mathematical concepts.